As a young citizen of India, armed with technology, knowledge, and love for my nation, with a vision of transforming India into a developed nation, I'm joining Shobhit University. What about you?
Very good morning to all of you. Shobhit Institute of Engineering and Technology, Meerut, deemed to be university, and its centers of excellence, Center for Informatics Development Solutions and Applications, and Center for Industry 4.0 Technology Studies and Applications, welcome our guest speaker of today's webinar, a serial entrepreneur, Mr. Raj Vankapandu. He is the president, German University, Germany, president for Indian Affairs, European Center for Mechatronics, Germany, founder, Indo-Euro Synchronization, Germany, member, NYS Committee, Industrial Robotics and Electronics Skill Council of India, and the participants from India and abroad attending this webinar. International webinar series on open source digital technology towards self-reliant India, Atmanirbhar Bharat, happens every Saturday at 11:30 a.m. to 1 p.m. Indian Standard Time. Today is 16th January 2021. Under this international webinar series, these two centers of excellence of the Shobhit Institute of Engineering and Technology, Meerut, Center for Informatics Development Solutions and Applications, and Center for Industry 4.0 Technology Studies and Applications, have organized 18 lectures so far. Open technologies to provision simple and economical IT infrastructure. A roadmap for students using free and open source software. Open source software and industrial IoTs for SMEs. Free and open source software adoption and business models. Open data platform for smart digital government. Technology imperatives, make in India for self-reliance. Edge artificial intelligence. Data governance for self-reliant India. Digital India transforming governance and society. India email service citizen at indiamail.com for in 22 constitutionally recognized languages. Ecosystem architecture for digital transformation. Education system cyber critical infrastructure. Seizing opportunities in open innovation and value creation network in the digital world for self-reliant economy. Ensuring food security and compliance through technology. Digital India, urgent need for semiconductor manufacturing in India. Technology investment in agriculture value chain, role of foreign direct investments. Entrepreneurship and skill development, artificial intelligence design pathways. The rise of platform economy, revisiting value chain governance. Today is the 19th edition of this very important webinar series. Today we will have the talk by a young serial entrepreneur of international standing, Mr. Vankapandu Venkata Nagaraju, alias Raj Vankapandu, on the topic, the era of automation, industrial robotics and industry 4.0, Indo-German perspective of technology transfer, skill gap analysis and opportunities. In this webinar series, the topics are a growing list. We consider technology imperatives, technology investment, open technology, open systems, open infrastructure, open source software for open infrastructure, open hardware for open infrastructure, open data platform, open banking, open insurance, open innovation, value creation network, human resources development, entrepreneurship development, skill development, startup in open technology applications, open society, society 5.0, industry 4.0, and we would like to work in the direction of pharma 4.0, textile 4.0, agriculture 4.0, industry 5.0, mass customization, and cyber physical cognitive systems, edge computing, edge artificial intelligence, data governance, digital India, India email service, open digital ecosystems, cyber critical infrastructure, dark data, dark cloud, dark web, dark net, technology enabled food value chain governance in platform economy, and urgent need for semiconductor manufacturing to make digital India a way of life in India. Atmanirbhar Bharat, the road ahead. Atmanirbhar Bharat is our Honorable Prime Minister of India, Mr. Narendra Modi's 5 I's to make India a self-reliant economy. The 5 I's are intent, innovation, investment, infrastructure, and innovation based on 5 pillars, namely economy, quantum jump, not incremental, infrastructure, one that represents modern India, systems, 21st century technology driven, vibrant demography, source of energy for self-reliant India, and demand, whereby the strength of our demand and the supply chain should be utilized to full capacity. This was announced on 15th May 2020 by the central government through a special and comprehensive economic package of rupees 20 lakh crore that accounts for 10% of India's GDP to bring the economy back on track. Now we are witnessing a V-shaped economic resilience in India. Our Honorable Prime Minister also has voiced that vocal for local to make it global, a demand-based economy system which is self-producing and self-consuming, make in India, make for India, and make for global. The reforms announced have been systematic, planned, integrated, interconnected, and futuristic for creating strong enterprises, generating employment, and robust supply chain. We are witnessing rising platform economy in the digital world, application of big data, new algorithms, artificial intelligence, blockchain technology, open API, and cloud computing is changing the nature of work and the structure of economy. Digital platform economy is emerging. Digital ecosystems are essential for digital transformation in the digital world. For a common man, what is digital example? We have seen digital media platform, Facebook, Twitter, Instagram, LinkedIn, knowledge platform like Quora, Yahoo Answers, Stack Overflow, media sharing platforms, YouTube, etc. Service-oriented platform, Uber, Grubhub, Airbnb, etc. Digital platforms are considered crucial for industrial modernization. India's promotion of digital platform economy rests in Digital India 2015, Make in India 2015, Skill India 2015, Startup India 2015, Stand Up India 2015, and Atmanirbhar Bharat 2020, Make in India, Make for India, and Make for Global, and Mission 2022, Connect India, Propel India, and Secure India. European Union has desired to convert chiefs of SMEs to AI-enabled e-leaders. Good ICT infrastructure is needed to help SMEs move into the digital economy. There are more than 3,500 urban clusters of SMEs, more than 18,000 of rural clusters of SMEs, and lakhs of khadi and village industries in the country. I wish to quote the related talks by experts in this webinar series. On 12th September 2020, Open Technologies to provision simple and economical IT infrastructure. On 25th September, Open source software and industrial IoT for SMEs. On 17th October, technology imperatives, Make in India for self-reliance. On 31st October, data governance for self-reliant India. And on 7th November, Digital India Transforming Governance and Society. And 21st November, Ecosystem Architecture for Digital Transformation. On 5th December, by Dr. Jabamale Vinanchi Arachi, former Principal Advisor to Director General, UNIDO, talked on seizing opportunities in open innovation and value creation network in the digital world for self-reliant economy. Era of automation, industrial robotics, and Industry 4.0. Information theory of Claude Zenon, 1948, to Internet of Things of Kevin Ashton in 1999 have impacted digital technological applications very decisively in various developmental fields. Fourth industrial revolution, Industry 4.0, is the ongoing automation of traditional manufacturing and industrial practices using modern smart technology. Industries are aggressively embracing major digital transformation, moving towards Industry 4.0 and fusing material and virtual worlds into cyber physical systems. The key technologies are A, B, C, D, E. A means artificial intelligence, analytics, and operation research. B means blockchain. C means cloud, IoT, and 5G communications. D means big data, and E means ecosystem. We have seen Industry 1.0, Industry 2.0, Industry 3.0, and Industry 4.0, and now Industry 4.0 is today, and Industry 5.0 is tomorrow. Industry 5.0 is starting to take root in factories today, and the collaboration between man and machine will continue to advance. The future holds infinite possibilities for human-robot collaborations. Sensors are the eyes and ears for Industry 4.0 technology. Automation is the creation and application of technologies to produce and deliver goods and services with minimal human intervention. Industrial automation in the Industry 4.0 era is called the digital shop floor. Robotics and automation, intelligent sensors, cloud computing, 3D printing, RFID, etc. are the foundation of fourth industrial revolution. Robotics in the age of Industry 4.0. Artificial intelligence and data analytics will make robots more productive. Predictive analytics, which is the ability to understand what is going to happen before it actually happens. As robots use more sensors and become more digitally connected, they will become much less susceptible to disruptions. Industry 4.0 is important from a robotics perspective because it will enable manufacturers to better understand how automation can improve process efficiency, product quality, and safety. As the Industry 4.0 landscape unfolds, collaborative robots called cobots and automated mobile robots, AMRs, will play an increasingly important role in smart factories. Cobots are smaller, more dexterous industrial robotic arms that enable human-machine collaboration without the need for complex programming or external safety infrastructure. Future employees will continue to play an important role as a collaborative co-worker to supervise and ensure that work is done smoothly and safely. Smart factories is the wave of the future. Smart factories will be intelligent and automated factories where machines are networked with each other, able to diagnose and solve problems by collecting and analyzing big data in real time. Smart factories are the logical, intended outcome of Industry 4.0. Smart factory automation will be driven by artificial intelligence. Another aspect one has to look into is robotic process automation is a critical innovation within Industry 4.0. And Industry 4.0 will, also will drive holistic supply chain management in industry automation. As of now, 8 specific technologies have been identified as assisting in bringing about a more collaborative and connected supply chain among modern-day manufacturing facilities. They are artificial intelligence, advanced analytics, data ledger technology, Internet of Things, smart mission, chatbots, autonomous robots, virtual reality, and augmented reality. The most crucial step towards implementing Industry 4.0 involves the integration of pre-existing business systems such as computer-aided drafting, computer-aided manufacturing, enterprise resource planning, manufacturing execution systems, and the product life cycle management. According to UNIDO 2018 report, it talks about Industry 4.0 opportunities behind the challenge. It talks about challenge and also talks about opportunities. Challenges of Industry 4.0. Number one, infrastructure gaps. Number two, outdated international rules and regulations that do not make into consideration Industry 4.0. Standards in interoperability, data ownership and security, incentives and obstacles that may shape the development and diffusion of these new technologies, that is intellectual property protection and others, reliability and stability of cyber physical systems, transparency, privacy, ethics, and security, inequality and exclusion, changes in the very nature of innovation process and the implication for competition and barriers to entry. The report talks about opportunities of Industry 4.0, economic gains, such as increased revenues because of lower transaction and transportation cost, more reliable and consistent productivity and output and better quality products, shift to mass customization with increased role for SMEs, enabling innovation across many applications with much larger economic impact on growth, energy efficient, and environmentally sustainable production and systems, effective use of human and material resource, increased food security and safety, improvement in the health and safety of workers, changes in education and training systems, more open innovation system, changes in the organization of work with remote, flexible, and on-demand work becoming a standard. Steps taken by Government of India to promote adoption of Industry 4.0. It announced National Advanced Manufacturing Policy in 2017, National Program on Artificial Intelligence in 2018, established Center of Excellence on IT for Industry 4.0 in 2018, Mission on Cyber Physical Systems in 2018. One of the key strengths in favor of India's foray into Industry 4.0 era is the country's, about 155 billion US dollar IT industry in the country. In order to promote through academic institution, Sobit University has established Center for Industry 4.0 Technology Studies and Application in collaboration with industry Acetal Technologies in 2018. We have resolved to promote Industry 4.0 technology pillars in SME sector, health sector, and agricultural sector. CISA provide industry 4.0 technology aligned skill development and entrepreneurship development program through certificate of competency, certificate of awareness, MBA in Industry 4.0, PG diploma in Industry 4.0, and diploma in Industry 4.0 programs. New opportunities will open up for SMEs with the industrial Internet of Things and e-commerce platform where they can offer tailor-made services and products using digital platforms. And the motivation factor for the university to establish the Center for Industry 4.0 Technology Solution and Application in collaboration with Acetal Technology was to promote Industry 4.0 in MSME sector through appropriate research, education, skill development, and entrepreneurship development programs. In India, this needs to be undertaken in a missionary mode. I'm also very happy to inform that MESA chapter in India was also launched from this Center of Excellence in 2019. COVID era has given an opportunity to us to work for promotion of Industry 4.0 technology for SME sector through such webinars. Success comes from as to how we understand Industry 4.0 design principles. These have been categorized into as below, and each category is itself a complete value system: interconnection, information transparency, robotic type technical assistance, and decentralized decisions. Let us now turn to the address on the era of automation, industrial robotics, and Industry 4.0, Indo-German perspective of technology transfer, skill gap analysis, and opportunities by Mr. Raj Vengabantu, our guest speaker today. The topic will motivate and galvanize the participants watching over telecast through facebook.com/Soviet University India or youtube.com/Soviet University in for motivating them to establish Industry 4.0 startups to facilitate digital MSME platform, particularly for the Indian MSME sector. Robotic process automation through virtual software agents and physical robots provide enormous opportunities for products development by emerging technology startups. Let me introduce our guest speaker, Mr. Vengabantu, to the participants through this webinar. Mr. Venkabantu Venkata Nagaraju, alias Raj Vengabantu, is the president, European Center for Mechatronics, Germany, president, German University for Advanced Studies, course director, Export Academy, Baden-Württemberg, Germany, CEO, Indo-Euro Synchronization Private Limited, National Occupancy Standard Committee member, Automation and Electronic Sector Industrial Robotics, Skill Council of India, Skill India Mission, Government of India. Mr. Vengabantu Venkata Nagaraju is an young serial entrepreneur, had a fleet in international business world in the fields of aerospace, automobile, mechanical, and information technology. He is basically from Vijayawada in Andhra Pradesh. Being a technology enthusiast, he always used to be in a search of technology and opportunities across the world since his childhood. In this process, he has been to several countries and currently he is residing in Germany since the last 5 years. Mr. Vengabantu finished his graduation in the field of aerospace engineering and accomplished his master's degree also in the same field from RWTH Aachen University, Germany. During his bachelor's and master's studies, he was associated with the complex projects in Indian Space Research Organization, ISRO, Sriharikota Rocket Launching Station, India, and Supersonics and Hypersonics Department at German Aerospace Center, Germany. Projects like optimizing the acoustic noise at launchpad during spacecraft launch, rocket cone aerodynamics analysis, Mars capsule base flow analysis, etc. He entered into the entrepreneurship world in his early career, and as of now, he is holding responsibility as a director in 4 different international companies located various countries like Germany, Finland, Netherlands, and India. Being an entrepreneur and observing the technology like in Indian SME sector, he took a wonderful initiative towards India for upgrading the technology from university level itself in the field of research and innovation by founding Indo-Euro Synchronization. Further, it as a German Center for Advanced Studies. In this process of technology upgradation, he joined hands with world-renowned research centers and took an initial step in the field of industrial automation. Currently, Mr. Raj is establishing industrial automation labs at Indian academic sector with the cooperation of APS GAP, European Center for Mechatronics, along with various academic and research activities to support the manufacturing ecosystem in India. Recently, he has taken one more responsibility as National Occupancy Standards Committee member at Electronics Sector Skill Council of India under the Skill India Mission by the Government of India. Through this, he will be able to support Indian students in a better way towards their academic and career perspective level, international level, and also establishing German automation and mechatronic companies in India through the state-of-the-art common facility center developments, along with achieving the academia industry collaboration. His fantabulous work supported or created awareness to more than 10,000 students across in India, along with the establishment of 50 plus Industry 4.0 and Industrial Robotics Center with the support of Indian and German government initiatives, which was also recently recognized as India Star Independent Award 2020 and featured in the Forbes magazine. We welcome Mr. Raj
Thank you.
Bhagavan to be our guest to address our webinar series on the topic Era of Automation, Industrial Robotics, and Industry 4.0. Thank you. Over to you.
Thank you, Mr. Moni, for the elaborated introduction about the Industry 4.0, and also thank you for the wonderful lines about me. And to the wonderful audience, very good morning in the Indian context. And today I heard that I also have an audience from the Africa and other countries. So whatever the time regions, the very, very wishes from India. And I'm happy that I'm in India and also enjoying the festive season in India now. And let me share my screen. So rather than the giving information or going just through the slides, I try to maintain my presentation today more interactive by showcasing some of the benchmarking analysis also from the various experts. Of course, we all like physical interaction and also interactive mode, but so thanks to COVID, it given a chance to bring all the points together in a very sophisticated way, very faster way. Otherwise, if we want to do this kind of international series, we need to have a different planning and a different understanding, different timelines. But this given opportunities to bring the coordinates very near to the world, wherever we are sitting. Even today, I'm sitting in one of the remote place of India, but I still able to connect to the entire world. But at the same time, we are unable to interact physically. But okay, this COVID situation will go away very fast. And I am very happy to announce like Professor Moni given a wonderful elaboration about Industry 4.0. Actually, that is the reason also in my presentation, I did not want to have a what is Industry 4.0, what is automation. I don't want to go in this kind of interaction today. So I would like to showcase this era, what we are observing, what world is observing, what third developing nations are observing, what developing nations are observing, and also some of the results from our work. This was the reason when Professor Moni was talking to me about the talk, then I would like to bring and I would like to take a very broad perspective and also benchmark and give a solution to it. Okay, before actually starting again, once again, very good morning, one and all. Thank you, Professor Moni, for this opportunity. I'm very happy and glad to interact with such a nice, wonderful audience today. And welcome to the topic. Of course, everybody speaking about 4.0, fourth industrial revolution and all. At the same time, what is the ground reality is happening? What are the steps we need to take? If we are talking about Industry 4.0, maybe are we need to be in already Education 5.0? So these some kind of interactive aspects we are discussing today. Great. So I am taking the German perspective because I am actually living and developing and implementing since last 10 years in this field. Even though I'm an aerospace engineer, this is given a chance for me to engineer to understand things and also to take the things forward. What is required for the world. Okay. So as Professor Moni already given introduction, so this is what about me. I don't want to go what I did and what I did and what I did not do all the things here. What I'm going to present here is, so we are trying to connect the dots between the Germany and India or Europe and India, or maybe to other countries. Actually, I supposed to visit African countries a couple of months back to take this kind of a vision forward to other countries. So being founder of Indo-Euro Synchronization and German Varsity, we are connecting the dots between how the technology transfer can be happen between one point to other point. And being a president at the European Center for Mechatronics, we are bringing the several decades of mechatronic experience to the entire world. and happily the new responsibility as a government representative or being a NOS committee member to create a standardization of the trainings and the processes, how we can take it forward under the Electronics and Automation Skill Council of India. We are working on that. I'm happy to share this information. So I believe in the audience, I will be having a blend of people like the promoters and teachers, professors, SMEs, and students, and also the graduates. Then we can talk all the points today. Great. So I'm trying to take my talk the perspective of what implementation practices we have done and what actually the implementation practices we have observed is successful. So when we started this kind of initiation, so we actually started creating some kind of the innovation factory environments in India, where the source of knowledge and also source of economy and the requirement is combinedly having at one place, creating a knowledge and technology transfer in a win-win-win situation. So this kind of ecosystem actually I observed through the Steinbei's concept from Germany, where I also work very closely with them. And by taking this kind of initiation, we try to provide the German expertise and support the Indian academic and industry issues. So that's how the dots connected from that particular point to the next point, by saying that how to create this kind of ecosystem by implementing the Industry 4.0 laboratories. And now we are happy that more than 50 plus locations, the German technology laboratories we have established, and more than 2,000 students are able to take the virtually, and also few hundred students are able to take the physically at these locations. So in the future, in the similar kind of the ecosystem, we would like to bring in the research and academia to support the industry requirements and also industrial growth in the particular countries, in order to create the Indo-European University Cluster presence, where the international global education will be coming forward, where we strongly believe education is our future. Let's work together on that. There are a few numbers, so actually even Forbes recognized. So before actually getting into the explaining or getting into the era of Industry 4.0 and what basis actually I'm talking today. So this kind of the numbers actually we achieved since last 6-7 years, where we are having a 5+ state collaborations from India, and we're having a networking presence of 10+ countries and 25+ universities and academic research institutions across abroad, even from majority of our presence from Germany, but still other industries also, other countries also are participating in our activities, and established more than 50+ advanced robotic control laboratories, which is we are calling as a Industry 4.0 centers now, and 75+ universities. And of course, we also invited the international students to have the experience in Germany. More than 500+ alumni we are having now. So as I mentioned, 2,000+ and 10,000+ students are getting this advantage. So on this basis, on this experience, the today's agenda for our next minutes, how we are going to formulate it, and also definitely not avoiding to understand the new normal, how we are going to adopt this new normal. And by having this kind of basis, we are actually trying to focus on 4 points. Of course, now in the 60 minutes, we are not going to expertise in one particular topic, but this is going to be a glimpse. And I believe our relation and our learnings will be continuing with us or with someone else later, which will be a very, very important in the current world. Now, so while moving to the era of automation, so as Professor Moni already mentioned to us, and also what are the topics we are actually working on, the main goal here of the companies are technology will be are supporting the labor. Companies will seek opportunities to develop the human-like intelligence that will take or cognitive tasks currently administered by their workforces. Engineers will become a fundamental or foundational to leveraging the technologies or technical platforms for delivering and sensing the data collection capability to firms, allowing them to automate processes that previously required a human in the top. For example, if you see the picture, actually what I what I am actually showing here, it is actually the SOAR robot from the Rethink Robotics. Actually, I also personally witnessed this robot, how they are actually implementing the robot and human working together in the environment. So initially, like before we are having like a human working, later like robot human working, then again the robot working. This is nothing but the industry 4.0. What fourth industrial revolution we are talking? The communication between the mission to mission, the interaction between the mission to mission. So whatever the five pillars or eight or A, B, C, D, E, what Professor Moni has been mentioned, these kind of all benchmarking, all the value additions is coming to this kind of the machine to support to actually having a precise solutions for the human achievements or human tasks, this kind of thing. So one of the major development here is not only having big industrial robots and manufacturing sectors and all, having some kind of a collaborative robots and cobots, even a small scale robot having more communicative and producing results, and also telling what is the problem they are having in the particular line of production, or in the line of what is the result oriented task what human giving to them. So in this era of automation of industrial 4.0, the robot is not limiting themselves as a just a machine, adding some additional component like the vision and also high computing power and also the sensing technologies, and capable of actually maintaining a powerful software. This kind of additional value additions of a robot is becoming a robust to provide our solutions. And of course, at the same time, the countries, the third developing countries, and also the countries or SMEs or MSMEs who are looking for the room of improvement, where the disruption of technology is happening, not only MNCs, their suppliers also getting famous, or their suppliers also getting updated or upgraded or upskilled towards Industry 4.0. Low cost automation also very important. Even one of our very successful practice is having a low cost automation processes and centers in academia to make students and researchers and professors to understand how the processes can be developed, can take it forward. So before actually continuing my talk with you, let me share how this artificial intelligence and everything actually adopting into the industry. The source actually I taken from the BMW manufacturing plant. So let's look into how the just 2 minutes video, how it is representing AI into the manufacturing field. So in this way, how different measuring systems, even if a human want to actually create any disturbance in the flow, how one robot system can actually indicating the human is actually presented in this video. So it is nothing but the mechatronics engineering, while featured heavily at the system level, organizing interconnected production structures that communicate each other in real time. If the world to adopt the grand vision of Industry 4.0, then it will need to people who understand how the various components work together. So if you see in this video, so you can observe that how the human and vision systems and also the production line and how the AI adopting into production line is observing in the current application. So this is not like what is the next generation is doing. It is not like actually what next month or next year or next decade we are doing. It is currently the implemented activity, what we are trying to adapt and actually make system process more comfortable to our life, system process, how it will be useful for our applications in the current generation. So in a similar manner, how and what kind of a system level engineering in this era will be useful, and how we are actually creating our system. So mainly to create a lower the cost. So how this mechatronics will be useful to our human mankind by creating of greater flexibility, maybe by having less number of the hassleness for the human. One such example is actually we can take machining. So where actually the benefits of machining with robots is making them an increasingly popular option for the manufacturer for the large. When we're actually dealing with complex items, complex issues, then there is a large demand of actually maintaining the precision, quality, because at the end of the day, customer is very important for any client. So customer satisfaction, even the service satisfaction, these are the main goals of any automation or a robotics or fourth industrial revolution actually bringing onto the table. At the same time, some kind of cloud activities where the cloud is the linchpin of entire Industry 4.0 project nowadays, where it provides every element in supply chain with the ability to communicate with every other in a real time, whether it is a sensor or sensor on a vehicle or a manager at a warehouse, or with everyone in the network able to collect the data, analyze it, and make decisions. Companies will be able to leverage their insights and adopt changes in the circumstances at fact. Mechatronics, therefore, will continue to rely heavily on the cloud as the scaffold on which to drape interconnected solutions. The cloud makes real-time reporting, logistics, and automation more manageable. So this kind of cloud linkage and automation linkage and the process linkage, which is defining this era now. So I also would like to show one video from the Wall Street Journal. So this video actually giving some kind of explanation by taking the perspective of the industry and also the worker and also the product. Let's see it.
Some economists say the world is entering a second machine age. Artificial intelligence and other advancements enabling robots to do tasks that until now only human eyes, minds, and hands could handle. For this episode of Moving Upstream, we traveled through Asia to meet the next generation of industrial robots, where robots are making robots.
Wow, they're making love for these robots. Keep making babies. Yes, right.
To see how they're changing manufacturing and whether they're sealing the fate of low-skill workers. Every other year, Tokyo plays host to the world's largest robotics trade show, IREX. It's no coincidence the show is in Asia. Here, robots are being bought and sold in numbers unrivaled anywhere else in the world. These are the types of robots Professor Erik Brynjolfsson is keeping an eye on as MIT's chief scholar on the digital economy.
we used to have to really painstakingly teach the machines step by step, program them what to do. And now machine learning is enabling the machines to figure out on their own how to solve problems. You put together the algorithms, the data, and the computer chips, and you get sometimes a millionfold improvement in the performance of these systems.
A millionfold improvement?
Yeah.
And what does that allow you to do?
So one really important thing to do on the factory floor is just be able to recognize objects. And that's something that only humans could do well until recently.
At IREX, we witnessed a robot handling a task that I, as a human, don't do so well, futzing with one of those pesky tape dispensers. It's among the latest offerings from Yaskawa, one of the world's largest manufacturers of industrial robots. Its main sellers are large industrial robots that do dangerous things like welding car parts. We visit one of Yaskawa's robot manufacturing facilities in the southern port city of Kitakyushu. Here, the public can try controlling and racing against AI-enhanced robot arms.
You're done.
We got to see where the robots are made.
The robots themselves, they're sealed off by these plastic barriers. The workers aren't allowed to be in there while they're in operation because they're making these very fast movements.
The head of the robotics division at Yaskawa, Masahiro Ogawa, seems most excited to talk about robots that don't need to be walled off from humans, that work alongside employees. In the industry, they're called cobots. The International Federation of Robots predicts in coming years, cobots will lead the robotics industry. That's partially with driving startups like China-based Elephant Robotics to get in the game.
Heated people, so it will just stop.
Yeah.
So work with people.
Yeah, works with people.
Yeah.
We asked their founder, Ju-Yi Song, how his cobot is different from traditional robot arms.
It moves not that quick, and it is very, very light.
Okay.
So it can work with people. So this is the most important thing.
In addition to being safer, the collaboration proves to be more productive. A study conducted by MIT researchers found that human-machine groups were more efficient than teams wholly comprised of one or the other. They also reduced human idle time by 85%. While traveling through Japan, we visited Huistenbosch, a Holland-themed amusement park. There we checked out its latest attraction, a robot restaurant.
How many okonomiyaki pancakes can the robot make in an hour?
今のロボットで焼ける枚数っていうのは1時間でだいたい5、6枚ぐらいだと思います。まだまだそんなに早くない。でも、それだけ丁寧に作ってますから。
My colleague Matt McDonald, after getting a robot mixed cocktail,
Kanpai.
tried the robot chef's signature dish.
よく日本ではどんどん少子高齢化で、特に若い人たちの人口がこれからどんどん減っていく、これがもう目に見えて迫っている状況ですから、じゃあいかに効率的にこのレストランのオペレーションができるのか、いかに少ない人手で。
It's gimmicky by design. Back at Yaskawa, Ogawa tells us most of the customers who come to him looking for new automation solutions come from China.
China market huge, and the growth ratio very high.
How high? Last year, Chinese demand for robots grew more than 20%. One reason for that is China's working population is aging. By 2060, the average Chinese citizen is projected to be 50 years old. To see the impact of industrial robots on manufacturing in China, we traveled to an area that's considered the electronics capital of the world, the Pearl River Delta region. Headquartered there is Rappu, China's largest keyboard and mice manufacturer. We asked the CEO why his company is making the move towards robotics.
Because in China have a rapid salary increase beginning from 2008. So we feel the little pressure from the labor side. So we decided to change a lot our manufacturing system to robot.
Wages for the average urban employee in China have more than doubled since 2008. Rappu, he says, in the past few years, used robotics to reduce its factory workforce from 2,500 people to now 1,000, and more automation is on the way.
So you're bringing more robots in.
Yeah, and then make even the logistic will use a robot.
You seem very happy about this.
Yeah, because it will make my company more competitive in the field.
And you're not worried when you lay off those 700 workers?
No, they can easily get jobs, no problem.
China's unemployment rate is 4.6%, pretty low. And the Chinese government says it's even lower in urban areas.
Most of them are getting jobs. They're not having to go back to the farm.
They cannot go back. And right now,
go back?
No, but they can go back, but for them, it's no meaning to go back because they will easily find another job because China is growing very fast.
When we talk to CEOs in China, do you think they're being forthright? Do you think they're being accurate?
Broadly, I think they are. I think that there are going to be lots and lots of jobs that are automated, millions, hundreds of millions of jobs that won't be needed because robots will do them. But there's no shortage of work that only humans can do.
Indeed, in China, the category of jobs that are growing fastest are in the service sector.
Is there any resistance from workers to putting these new robots in?
No, because they have no choice.
Your plant that you oversee has already been automated 80%, you said. Do you see it going the rest of that 20%?
Li Zhendu, a worker at the Rapu factory, has watched as robots have replaced his colleagues.
How far off do you think we are from full automation? Nobody left working in your department.
这个要根据公司来决定这个如何。具体的话还是看公司层面。
Chinese delivery company JD is showing how automation is advancing in other industries like logistics. There are still some employees here, but not at a JD sorting center near Shanghai. It's taking nearly all humans out of this process. And this is the same company that last year began making drone deliveries.
This is a moment of choice and opportunity. It could be the best 10 years ahead of us that we've ever had in human history, or one of the worst, because we have more power than we've ever had before. Tools by themselves are not going to lift up the billions of people who are being left behind. Those are conscious choices we have to make as a society and as individuals.
In just 6 years.
Interesting. So if we the time spent last 6 minutes, actually, if you observed, the service sector is also using the robots. And actually the CEOs is considerably very happy that their companies are actually getting a competitive. And even the robots and missionaries, they are actually getting more smarter with the sensors and communicating. Even actually the employees are saying that actually they're missing the colleagues, but actually undoubtedly the new opportunities are increasing. So in this way, how the business process is improving, and also in this era of this automation, is one very, very important point for is the job sector.
Some economists,
the job sector and how job sector is actually affecting, and the business grows and the business proceeds. For the economy to progress, however, business will need to find the ways of combining these technologies to create more efficient and automated systems. Home assistants like Amazon Alexa are also helpful, but at the same time, intelligence can only take us to so far to the next level. But at the same time, it is also very important for us to think about what jobs for tomorrow. Although number of jobs are destroyed, the new jobs are created. So the people and actually who is sitting actually behind the improvements, actually who are not exactly in the manufacturing lines, they are only the people actually who are concentrating like, okay, why so much of automation is happening. This might actually disrupt the complete job market and all. That's absolutely not correct. In the skill gap analysis, I'm going to show the recent study of the World Economic Forum, how the jobs actually and redesigning and reskilling and also taking the things into the next level. So these are the very important coordinates of now in this era of automation, improving the system processes, and also having and connecting the dots between the industry requirement and the human requirement, and also bringing and inviting the robots into our service sector. So we don't need to worry about the jobs for tomorrow. Definitely the jobs are going to be improved. At the same time, the automation process need to improve, and also the coordination of automation and jobs need to be recognized. Just further, so until now actually we spent our time on understanding actually how this era of automation is happening, how these jobs are affecting, what are the services and how the coordination is happening. And the students, if you observe and if you see the video what actually I showed, the number of the robots and robot engineers are increasing day by day. And also especially the countries like the developing countries like India, and also African region, and also other regions of Asia, it is very, very important for the students to identify the better skill to get employed. It's very important. So in this perspective, in the next minutes, I'm going to talk about how the advanced country like Germany, in studies, in the research, and also in a provision of technology to other countries, how it is helping. But before actually getting into that perspective, let's experience about the country and what exactly and what kind of shocks and surprises what student will get or researchers will get from. I take a source for an interactive way from the Study in Germany website. Let's have just spend some few seconds on this video. We'll be understanding what kind of the different perspectives of Germany here. So in this 1 minute time, I think you actually gone through the some kind of the visual experience of actually what actually that also needed to achieve something, the developed technologies, and also we will be having some kind of a cultural shock, and also chance to learn, and also ladder of opportunities, supporting of leadership, understanding ecosystem, and personal life. Everything is actually going to give a different perspective of improving this kind of experience when we're talking about Germany here. While moving forward, bringing the German perspective and to the Industry 4.0 or Industry 4.0 analysis, first let's understand what kind of different skill requirements we are having. So this is actually a little bit of vault analysis, but I still want to take it. When Professor Boni was actually mentioned the agriculture 4.0, industry 4.0, service 4.0, and all these things, the Indian ecosystem already benchmarked it in each department and each division, there is a requirement of millions of skill gap people. So in the infrastructure, we are actually looking into it. Automobile, we are looking into it, and also building, textile, transport, and food processing, healthcare, real estate, and retail, and also education, and also in service providers. Not only this, and as we are actually concentrating automation industry 4.0, and now we are also having the COVID impact on our lives, and how it is actually this analysis going in the worldwide. Let's look into it from the research work of World Economic Forum, how the robots actually supporting the human beings, and what kind of the rebuilding a new job market and new job analogy is actually happening. And for the student or the professor or the university or the SME or industry, how and what is the process they need to develop. So let's look into it. So if you observe how many millions of new roles created, and how the companies itself, they're asking how to change the things and how to take the things forward. And in the mechatronics perspective, actually what we are talking in this point of now. So before actually getting into this kind of understanding about how this complete process is changing, we observe that there is a blended approach need to be developed. So where the bringing technology and these things together, where the learning will be much more easier and creating excellent platform. And that's how the partners are committed in providing these things actually to the students in a different level, and also our organization actually also taking forward and bringing the coordinates together. So what we actually created here is we actually believe some kind of the pyramid approach for this kind of thing, where the academia on the industry and even the government processes and policies actually coming forward. And if you observe the list actually Professor Moni is provided, the every initiative, Make in India, Sustainable India, and also now Atmanirbhar Bharat, and all these things actually motivating SMEs and also MNCs to take actually to be a pride of change and to achieve this kind of results. And if I'm talking about SMEs, MNCs, and also the companies, so equally linking to the academia, the organizations, and also the students, you are the people who are going to implement it. So we are only creating the awareness of this ecosystem, how to take it forward, but you are the people actually how you are connecting dots to take it forward. And in the similar fashion, what kind of necessities actually bringing? So in our practices, what we have done is we actually try to develop the 3D view of necessities, or created the ecosystem of 3D views, where the governmental bodies will be understanding what they actually the other countries actually providing. What universities and colleges need to realize, as Shobit University already started the Industry 4.0, one of the kind of center there, and how the universities and colleges actually improvising by understanding the practices across the world, and also developing some kind of initiatives by themselves, the universities and colleges, and how the connecting dots by understanding the bilateral activities, and also students and researchers to take a point and make it sustainable and more self-reliance to get the results out of it. In the actually in the perspective of mechatronics, actually what we are talking now, it is very important to understand how the mechatronics engineer or mechatronic system support can be done, which means that in a short term, rather than attempting recruit mechatronic engineer, or the easiest or cheapest solution business will be outsource the mechatronics ecosystem by working with them companies who have expertise. This could have a number of advantages. So not actually bringing completely the conceptual level, also trying to take some kind of a practices. So to bring this kind of study practices, I would like to show what kind of study ecosystem Germany is providing, so which might be interesting also as a part of the opportunities creating in this ecosystem. So this 60 seconds will be giving a how German higher education system will be linking to the world.
Many young people from all over the world choose to study in Germany. 12% of all students come from abroad. So let's take a look at the German higher education system. In Germany, it's possible to study just about anything. There are over 18,000 different courses, including more than 1,800 international programs, most of which are conducted in English. With such a large range on offer, everybody finds their chosen subject. Also, when it comes to choosing a university or college, you have many options. There are around 400 state-accredited higher education institutions at around 180 different locations. Universities are strongly research-oriented and offer the widest range of subjects. They teach both theoretical knowledge and methodological expertise. Universities of applied sciences concentrate on the application of scientific knowledge and primarily teach professional practice. The range of subjects is focused on areas such as technology, business, social affairs, and media. Colleges of art and music train budding artists, musicians, directors, actors, and designers. The special artistic talent must be displayed in an entrance examination for these courses. A small number of courses are also offered at other specialized institutes. In Germany, there are public and private higher education institutions. More than 90% of students are enrolled in state-run universities and colleges. With such a vast choice, you're bound to find the course that's right for you. Let's talk about the various degree options. You can do a bachelor's degree, a master's, or gain a doctorate. In certain subjects, there are also other degrees, such as the Staatsexamen. However you decide, a degree from a German higher education institution will increase your chances for the future. The cost of living in Germany is moderate compared with other countries around the world, and there are no tuition fees at most higher education institutions. In Germany, you receive first-class education with degrees that are recognized worldwide, and you are also offered excellent support. Ideal conditions for studying a course that furthers your career, whether in your home country or in Germany. So, what are you waiting for? Discover your international side. Study in Germany.
So this video actually given some kind of glimpse, like what are the different study options, what you are having in Germany. And so actually today in my part of presentation, I am moving to the third part of the topic of the title, what we are having. So the students or the universities, you understand what is the importance of Industry 4.0, and actually Industry 4.0, the wings of it, like, artificial intelligence, machine learning, data sciences, and also IoT, which is very, very important. And also how this era is actually impacting and how these things are actually taking forward. And also I shown some of the benchmarking results from the World Economic Forum, what the future ready and job ready market is actually what we are looking in. And also I shown how the Chinese market already adopted and also achieved into the next level, but still such a big country is still the employment is still employment. New case studies are actually bringing. Similarly, we can easily compare the other countries with these technologies, we definitely can improve some kind of a beautiful and a wonderful job market for our fascination students. And so while I'm going to the next level of thing, even actually I try to spend all the time today's presentation how explain and sharing the stories from our practices also. So for example, if anyone want to study in Germany, and of course in our audience will be having the graduate students and who already graduated, and also the universities. So basically, in a German education or any the worldwide education, we are having like a different types of opportunities for having awareness, practice, and also achieve a degree. So in the similar manner, even actually our practice also we try to implement in the same system. Even the country Germany is providing this kind of opportunity like study visits, invite a student for a SEM exchange, and year abroad, and also the dual degree programs, and also invite some kind of invite students to have some kind of a hands-on, and also having a degree and coming to the masters, bachelors, this kind of thing. So here, this slide maybe actually will be showcasing how the bachelor studies can happen in Germany. And of course, there is a student colleague. Students need to achieve through the student colleague, which is nothing but the physics and maths and some kind of language exam for international student to actually joining to UG in Germany. And during a UG, you can achieve this kind of all these opportunities, and you can achieve the next level technology in Germany. So similarly, if you are not able to come to UG, or also this new normal, this new era of education, try to adopt the different practices. So even we thought like last 1 year because of the COVID, not only COVID became some kind of eye opener how we can actually achieve the different practices to provide and to achieve industry 4.0 in this era. So how to create some kind of a blended learning activities in advanced course. Of course, these kind of practices are already experiencing or already practicing since last decades. But what we try to do is we try to bring the points from the different corners where participations from German universities and research centers and all to create a blended and advanced learning courses, and that will be linking to some kind of a dual degree programs, master programs, and also the research activities. So what we try to impart here is we created a beautiful model to create some kind of unique framework from the multiple German universities. Because if any abroad university or abroad ecosystem they want to link to Germany, maybe they will limit it to 1, 2, or 3. But sometimes maybe South Germany is very famous for the manufacturing sector, where all automobile manufacturing companies are actually locating. So if you want to have this kind of courses, maybe it will be good to have some kind of interaction with those universities for those courses. And also Berlin is like a startup ecosystem. If somebody want to start something with good startup, want to have some kind of a information exchange or knowledge exchange, that part of the world is very better. So these are reason actually what we try to do is we try to bring the multiple universities and research centers to part together and create by launching the Campus 100. So this Campus 100 is actually we are inviting the different universities and research centers to be a part of it to create design a unique global knowledge-based programs where everybody can join. The interesting point for student here is what they are going to get. Okay, I'm studying a bachelor here, bachelor in mechanical engineering. We are then trying to facilitate them BTech honor degree in the robotics, a BTech honor degree in the artificial intelligence, BTech honor degree in the IoT, BTech honor degree in the aeronautics in this manner. So it's not limiting and confined to the only one technology. Let's be having a broad reskilling methodology and make yourself competitive and get ready for this kind of job market. This is very important for any learner, even it can be a student or a graduate or startup, anything. So these are the change makers in the next generation. So I think the era of talking about mechanical, electrical, ECE, EEE, and these things of course still continuing because the foundation and fundamentals are very important. Along with that, the perspective towards optimization, the perspective towards artificial intelligence, code it, get a experience, get a hands-on thing, IoT, aerospace, and data sciences and machine learning. So you see in the videos, the machine learning and machine interaction and machine communication is very, very important. So this is the topics actually where we are also focusing, and also the change makers, the professors in the universities, and it is also equally important what they need to actually spend their time in the next for next generation. So these are reason actually why we bring this Campus 100 initiative, where the multiple university and residents participating. And if you're a change maker, if you want to be an initiative change maker, you're always invited to it. So this is one opportunity I would like to, because as my talk actually focusing the opportunities and takeaways, the fourth point. So now I am actually slowly getting into my fourth part of my talk today. So what is the opportunities and takeaways actually one can look into it in today's your time spending, because time versus efforts versus money. So you are spending your time. So let's see what is the actual takeaways we can talk about today. So these are actually some of the partners organizations from Germany, Steinbach University, like a Steinbach Global University, Export Academy, and also Chamber of Commerce, and the Slingen University, Potsdam University, and also European Center for Mechatronics, and also partner institution is ETA WTH Aachen University. We are actually joining hands together to create this kind of advanced diploma certifications and actually earning honor degree for by doing this kind of activity for the students, and creating some kind of the module-based verticals where students can actually expertise in a different level. So this kind of a virtual skilling and making ready ourselves to the next gen education is very, very important. So virtual skilling and virtual laboratories becoming a very key role. And of course, not because of the COVID, I think I started talking about it since 2014. And so this is my 10th year in Germany. Of course, in my introduction, it was 5 years mentioned that 5 years is my leadership experience in Germany by being a CEO and the founder or president to the multiple organizations. So I went to Germany in 2010 as a student. And from that particular point, from my engineering experience and also working in the aerospace centers and all these experiences, this virtual skilling and virtual laboratories also redefining the skilling methodologies. This is why in 2014 I started talking about actually how these virtual laboratories can impact the education. So in this time, actually Industry 4.0, we are talking now in 2020 Industry 4.0, we're talking then in 2014. So already we started this kind of ecosystem. Now we're upgrading this ecosystem by showcasing our results. So in the next slides also, I'm showing how these results already achieved into the next level. So not only the research center and the thing, and also maybe I think Ethiopian University partners also joining this webinar. And this kind of a German dual degree program, German bachelor degree, like 3 years there, 3 years here, and also for Indian ecosystem, the Indian private deemed to universities and also several governments, we're talking about how we can create some kind of ecosystem. The 3 years can be student in India, 1 year can be in Germany. Of course, this is also not a new methodology, is already existing since few decades, but only to the partner university. But we are trying to impact more number of students. We are trying to support more number of students having this third year going to Germany and having some kind of experience and certification, and also getting a degree from German university. These kind of opportunities. And until now, I spoke about actually the bachelor level, and also what you can do during your bachelor's, coming to Germany for 1 year or 6 months, something like that. Not only that, we are actually trying to implement some of the practices by offering the master courses. So what we have done is we have actually chosen the master courses what German university is already providing. We redefined some of the curriculum by adding our industry partners to that. So for example, one such program, actually what I'm showing here is Masters of Engineering in Production Technology at RFH Cologne University. So what we have done is, for the basic and existing curriculum, what they're having, we started actually adding the low-cost automation module to it. And our partners, like a low-cost robot providers, IGUS and other partners, they started actually giving internships and also linkage to students and for the people who are actually joining this kind of master programs. And who are graduates now in the audience and also who are in the startups, it could be a good opportunity for them. So I have one more cookie for startups. I'm going to share into my next slides. So in a nutshell, so how this learning progress and learning process, actually how we implement it is. So for example, if somebody want to have an internship activity or 2 weeks exchange activity, we are providing under the banner of AutoSol. That how students can come there, can have experience, can actually achieve in a short duration some credit points, certification, these 15 days activities. It will create some kind of awareness and exposure to the student. From that level, we started actually creating project exchange or semester exchange, where the deemed university student can come 6 months to Germany, can have a learning practices in our partnering research labs, and can have some kind of certification and also bachelor thesis activity from Germany. Not only these things, as we are actually talking about some country which is not speaking our language and also who is actually very strong in the manufacturing. So that is the reason actually even we started some initiative with Indo-German Chamber of Commerce in a language initiative. Then this kind of short learning activities we try to link to the degree programs, like a master degree programs. So in such a way, we are actually providing a couple of master programs through us. So we are also having some kind of intention, like let's not have the consultancy approach to the students. Let's have students to come and achieve and take the opportunities with us and into the next level. And not only this, so when the student actually having presence at their home university, which is very, very important to have some kind of a international or technological ecosystem there. So in such a way, what I mentioned in 2014 itself, we had taken some initiative, the Applied Robotic Control cluster establishments. So we initially started Industry 4.0 centers establishments in the Indian academia. Then we started actually also starting some kind of the artificial intelligence hubs. So now all these actually points also, we are actually drawing all the coordinates to the one location as a opportunities at one place as a German varsity campus at home university, like German varsity campus at Indian academia, German varsity campus in African academia, or UAE, or also in Australia we're talking about. In this way, before getting into the Industry 4.0 and achieving the job role there, first let us prepare ourselves and let our students prepare themselves to achieve this opportunity. So just to showcase, even if you want to go to some kind of center or some kind of ecosystem, it is very important to have a good observation. What is going on? Why we required? Why really do I really need to run behind this kind of initiative? Do I really run behind to grab that kind of opportunity to achieve it? First, let's observe what your ecosystem is actually talking about, what you placed, and what you are actually want to achieve in the next level. So just 30, again 50 seconds video, World Economic Forum actually did benchmarking in one of the states of India, where we developed our Industry 4.0 centers ecosystem here. So let's see what World Economic Forum actually talking about. Great. So I'm not going to take much time. I think the next 4 minutes I'm going to conclude my presentation. And so by seeing this kind of observation, so what we have done, so let me showcase, like, after first cycle, when we're having a little review at the first day of 2021, what happened in 2020. So these are Industry 4.0 centers we have established in the state of Andhra Pradesh, across state. You can see the faculties travel to Germany, and also our faculties travel to India to make faculty development programs, and started students having experience how they're interacting on this kind of physical systems, and how this processes has been developed, how the low-cost automation robots participating in the activity, and even how the companies like Festo, and how they invited our students to becoming a interns with them, and even having even you can observe that even actually one of our students starts playing chess with the robot. This is not the Industry 4.0. This is not human and robot interaction. This is kind of the ecosystem we need to develop. Then obviously the students definitely is going to be having enthusiasm, and also it will also eye opener to them to have a different thing. So in this way we created our ecosystem and created impact in every district of one state, and in 31 locations of one state created this kind of outcome and success. And not only this, and not only in a COVID condition, by observing the results of this program, you can see how the different companies came forward in a core engineering, how they actually adopted the students to them next level. So irrespective of the COVID, we actually started exposing our students to the different multinational companies and their suppliers, and their suppliers able to adopt the numbers, and more than I think 80-90% of the students, they already see the opportunities with this kind of ecosystem. So our responsibility is creating this kind of ecosystem, and our responsibility to connect the dot and providing the high-end tech transfer activity, and automatically the jobs is not an issue. And so this is actually the point, actually what I'm actually talking about for the startups, for the industries, who the graduates. So we are also actually benchmarked some of the requirement, and where the students can start their work, start their startup in India, and that can actually give also the employment and job search back in Germany by joining the program like MA General Management or MA Technology Management with the Stein-based university, other universities in Germany. So these are also one live example. So if you observe that every point, I was actually relating to one of the practical possibility or opportunity what Germany is providing, whether it's our organization, whether it can be our partner organization, whether it can be someone else. So now, for example, if you're saying the Stein-based Global Institute based out of Tübingen is a part of the Stein-based University, Stein-based School of International Studies, they're offering the student can start their work in the home country and also taking to the next level by inviting them to Germany to get opportunity for a job or business expansion or guidance, etc. So until now we're talking about technology, until now we're talking about what are the opportunities and all. It is equally important what borders are saying, what embassies are talking about, what is actually the candidate profile is required, what actually conditions are required, where we can also help and to take the things to the next level. Great. So Professor Monique, can I continue? I have just 2 slides left.
Please carry on.
Okay, because this is a one academic initiative by understand the COVID, how the learning practices has been changed. So this 1 minute video is going to give what their initiative actually impacted in this COVID situation.
It's an awful time in the world, but I think it's a really interesting time in education. We've never had a moment like this one where everyone at the same time has jumped into this technology.
The coronavirus is changing life as we know it on a daily basis. In COVID 2025, we'll explore how the pandemic is rewriting our future.
The ability to teach through the technology is really powerful. I can lecture, I can call on students, I can engage in Socratic dialogue. I can replicate what I can do in the classroom. Things that have been hard in the past, bringing in guest speakers, being in multiple campuses at once, the ability to tie those together in a much more seamless fashion, I think that's exciting. Distance shrinks in this medium. I think we're going to see it used throughout education in the United States, at the pre-college level, college, professional level. That's exciting across the planet. There's definitely been a trend towards remote learning. I think that's been unevenly distributed. This is going to give us a second set of tools. We've had one way of doing things, and now we're going to have an additional way of doing things. And I think that's what's exciting. It's just like you're a chef or something, and all of a sudden I've said, here's an entirely new set of ingredients you've never worked with. To really make this technology work and to do so on the widest possible basis, we need to have the physical infrastructure in place to do that. So I'm sure you've been reading stories about what's happening at the pre-college level, places where they'd like to do online education and they don't have internet. They don't have a device to do that. We frame that as a digital divide. I'm teaching a class right now where we're talking about Federal Communications Commission broadband policy. Broadband's so incredibly important. So had this happened 10 years ago, I think we wouldn't be doing anything like we are doing now. When we built this country, we made a decision to make the post office, which was the most direct instantiation of the federal government. We put it everywhere, even in rural towns where there was no way that made financial sense, because we wanted everyone to be connected together in this new democratic enterprise that was the United States. Shrinking the digital divide is really about federal resources. The COVID crisis makes it clear how important this is. Privacy issues are obviously important. Now as we bring this into our educational environment, what am I allowed to screenshot? Can I take pictures of students? Are those educational records? We have a federal privacy statute for student records that controls all of that. If I want to use a camera to take a screenshot, it's not as visible as it is in a classroom. And so how we bring the right privacy values to this new environment is something we're going to work out. Law evolves in conjunction with social evolution. As technology evolves and how we're using the technology evolves, law comes along with it. I think we need to be careful with regard to this technology. I think there will be a temptation to think we can swap in technology for the in-person experience that shows up in a classroom. And I think that would be wrong. I'm staring into a camera right now. To the idea that we could put this camera in the front of the classroom and we've delivered an education, a rigorous education, an education where you test and consider ideas, reject some, accept others. I think it would be a mistake to think we can simply swap one in and swap out the other. We need to augment, not replace. 5 years from now, we'll be beyond the medical crisis, beyond the economic crisis, and we'll be able to take this technology in this period of experimentation, and we will have figured out really how to put it to use. I think that means that we will be shrinking distances. We will be able to bring people into a classroom in an easy fashion. The country, the world runs on ideas. We need to get those ideas in as many possible ways to as many possible people. I think this technology is going to help us do that.
The reason actually why I shown this video is, so this is the part of the initiative that University of Chicago has taken, but is equally important for every organization or every part of the world. It is their responsibility to take their initiative. And let's take our own initiative in this competitive or challenging world. And we are always there, even being an organization or being a founder or being a president or or being a human being, whatever the support, actually, we are very happy to do it for the education, what we are doing now. And yeah, so this is my last slide. So if you have any questions or something, so absolutely do not hesitate to reach us. And also do not hesitate to post a question to us, and open to the discussion on your behalf. Potential growth can achieve only together. Thank you. Thank you very much.
Thank you, Mr. Raj Bangabandhu Venkata Nagaraju. During this 1.5 hours discussion on the topic, the era of automation and industry automation, industrial robotics and industry 4.0, and Indo-German perspective, and skill gap analysis and opportunities. And I'm very happy to inform you and also thank you that you have done a very wonderful presentation.
Thank you.
Innovative presentation, galvanizing presentation. And you have made it in such a manner that your talk has answered many questions among the researchers, among the students, and also the practitioners. The videos which you have brought out from the point of view of theory of knowledge and application of knowledge. And this is a total value system which you brought it. You talked about industrial automation through industrial robotics with the application of Industry 4.0 technologies. It is a pillar of 9 technologies. How to prepare, in ecosystem. Can we have an artificial intelligence hub? Can we create an, academia hub? Can we create, various, exchange programs between India and German, depending upon where the students would like to do that. They would like to look for a startup, or you would like to look for employment opportunities, or they would like to create an employee, become an employee. And they also answered questions that how it can generate new jobs, how people have to be reskilled. Don't worry about the jobs gets destroyed. There are so many new jobs are emerging, and the workers are with knowledge built in over a period, how they can be reskilled with the new ideas, generations. And with this one, new products can be designed, and that customized product can fetch a high price. And the technologies are more important. How to create hubs of intellectual pursuit. I thank you very much. And there is a question from Dr. Faiz Akram from Ethiopia. His question, which you are also seeing it, how can robots have a positive and never negative impact on the community? Over to you, please.
The positive impact will be creating a seamless applications and seamless livelihood for the humans for a growth. The negative impact will be if you are not upgraded to use them. So I give it by answering a single statement in both the side. So if you're not upgraded, if you're not upgrading to use them, if you're not creating your ecosystem, so you feel that is going to be negative impact on a human mankind. But if you're upgrading, and this is a wonderful opportunity to create a positive impact across our ecosystem. So I think my special hello to Ethiopia.
Okay, he is from the Jumma University, Dr. Faiz Akram. Fine. And I know it gives. I'm very happy about it that now it is really attracting. And once again, he's asking, what are the ethical difficulty faced by robotics? Ethical difficulty.
I don't believe the robots will be facing ethical difficulty, because at the end of the day, we are the people who will be actually designing for the robot what they need to do. So while we are creating that ecosystem itself, actually we need to be very careful, and we should be very uh, uh, we need to have a very straightforward actually activity what the machines can be useful for us. So the ecosystem when we are creating itself, the draw line should be more ethical. The draw line should be more solution oriented. The draw line should be in support of the human effort. The draw line should be in support of human life. So in this way, mission will not face ethical difficulty. The person who is developing the mission or ecosystem, we need to define in the ethical manner. I hope I answered Mr. Fayaz.
Yeah, and in addition to what you said, the last slide which you have shown from other parts of the world, how the other countries have initiated COVID 2025 initiative. It is very important for India also. I am very much thankful to you to have the last slide that this has come from America. It's a developed country, but they are working on COVID 2025 initiative, how to bridge a socio-economic gap by providing internet, capability to everybody in America. That is true also in India when, remote learning is it is going to be the order of the day. And technology is affecting the educators. So every educator has to adopt technology-based, teaching.
Yes.
The students have to have a technology-based learning. It is a lifelong learning process. This is what the post-COVID situation has brought it. Because, otherwise you have to go to the campus and there is a bar on getting into the campus, on enrolling and so on and so forth. Today with the technology available, so many digital platforms, you have materials. The talk which you have got it now, it in another 2 minutes, it will be available as in the YouTube.
Absolutely.
And everybody can see it without any editing. And this is a real raw material for everybody to evaluate it, value it, and join back us with their own understanding. So this is remote learning. Technology is affecting the educators, so they have to prepare themselves and then provide internet capability to bridge the socio-economic gaps. India is having about 29 countries of different culture and different ethical practices and administrative support, and more than 750 districts. Many of the districts are more than some of the countries' size of the Western, other countries. And these 3 points, which the last slide which you showed, are very important takeaway. And you also, if you wanted to put it, you very, very nicely put it for startups. Whether you would like to look for a job search or you would like to provide employment. So go for an MBA in technology management. Facilities are available. Then you talked about, you've shown the glimpses of skill impact. That this is how blockchain is facilitating, how machine learning and artificial intelligence are used for designing products, and how artificial this augmented reality and virtual reality are used for skilling the workers, and cobots and robots are becoming robustic in nature to improve industrial automation. And then even a state in a progressive state like Andhra Pradesh, how they have got an innovative plan to add $5 billion economy through industrial automation, through application of Industrial 4.0, and in which $3 billion they would like to add it in automobile sector. It is very impressive in nature. And you also said it that before you get into 9 pillars of Industry 4.0, now one is being added with Industry 5.0, that human interface with the cyber physical systems, that how to create each technology wise some environmental hubs for students to undertake, for engineers to undertake, and the industry workers to undertake. And you also talked about opportunities available in German universities and also for Indo-German exchange programs. And you also talked about the change makers in the next generation, industrial automation, AI, advanced automobile, IoT applications, and above all, data science. And you also said it, be a part of Campus 100 program. That is the takeaway. You also can have a mini certification program, mini education programs, and exchange program between Germany and India, which you have facilitated. And then in the new era of new normal, how to have a blended learning for advanced courses, internship activities. And you said that if you would like to have an automation, you prefer exchange program with South Germany. And if you would like to have a startup ecosystems, you go to the other part of the country. So like this in India, we have got 29 states, provinces. We have to create such type of ecosystems, not all in one in every institutes. We have to have a different what do you call these ecosystems. And like I very nicely said it, I said it in Ministry of Heavy Industries also, that the Center for Industry 4.0 Technology Studies and Application of the Soviet Institute of Engineering and Technology, Meerut, would like to concentrate on that SMEs, how Industry 4.0 technology can impact SMEs, like what European unions are doing. We wanted to make SME CEOs as an AI-enabled e-leader. We have done it. Because this sector is done, it is 30 to 40% of our Indian export earning is taken care of. And it provides large scale of labor forces. 3,500 urban clusters of SMEs, more than 18,000 of rural clusters of SMEs, and more lakhs and lakhs of khadi and village industries. We can't just look at it only heavy industries. That is the practice in India. And so that's why, being the university in the rural part of India, we thought that consciously, with my vast experience as the technocrat of the country, I thought that SMEs is an important thing, because I was asked to deliver a talk in Madras Institute of Technology in 2004 or 5. I talked on digital SMEs at that time, 2004 or 5. And now 2016 India, people talked about Industry 4.0. When I was asked to talk in an Industry 4.0 technology launched by a company from Singapore, I said that this is the roadmap, we should have it. We would like to join, please join with us to establish a center of excellence. That's how they joined with us. And so we were very happy to how to interact, collaborate with your varsity. In Germany, you call it varsity. In India, we call it university. And so how to bring in large scale participation of launching, we have already launched an MBA program in Industry 4.0 for SMEs. So we would like to associate you with these programs to have an SME hub for Industry 4.0 technology in our Center of CITSA, that is Center of Center for Industry 4.0 Technology Studies and Application. With this, we gratefully thank you from the Soviet Institute of Engineering and Technology, Meerut, Dimtu University, and Center of Excellence of Informatics Development Solutions and Application, and Center for Industry 4.0 Technology Studies and Application. Thank you for your wonderful, thought-provoking, and galvanizing lecture on the topic, the era of automation, industrial robotics, and Industry 4.0. Industry 4.0, with the Indo-German, exchange program perspective and skill gap analysis and opportunities available. It is a complete value chain which you talked about it, and we would like to take this opportunity to promote Industry 4.0 technologies and also Industry 5.0 technology in the sector of Industry 4.0, Agriculture 4.0, because this is the only private university maybe in the world to have a center of excellence in agricultural informatics and e-governance research studies, and Center for Agribusiness and Disaster Management Studies. And as a Professor Emeritus and the former Director General National Informatics Center, I was associated with the National Task Force on doubling the farmers' income by 2022 in two subcommittees as a chairman, and worked on digital technology in agriculture, volume 12B, chapter 7, 8, 9, 10, and volume 11 on agriculture extension and ICT. And there we have in the volume 12B, we have recommended 7 mission mode projects for digital technology in agriculture. If these 7 mission mode projects are operationalized through such advanced technologies, Industry 4.0, and Indian economy, agriculture economy will be a digital platform agriculture economy. And with the 3 agriculture farm laws, which can facilitate creation of 1 agri startup in every Gram Panchayat. It means that this can facilitate agriculture 4.0 startup in the order of about 2.25 lakh startups in the country.
Wow.
This one is possible. So we would like to achieve it, and we would like to we are looking for a strong collaboration between your center in Germany and Center for Industry 4.0 Technology Studies and Application of the Soviet Institute of Technology, Engineering and Technology, Meerut, to further it. We thank you.
Thank you so much.
We thank all the participants for patiently listening this wonderful address in the international webinar series on open source digital technologies for self-reliant India, Atmanirbhar Bharat. For further inquiry, please email to me, moni@sobituniversity.ac.in, Professor Moni Madaswamy, Professor Emeritus and Chairman, CITSA and CITSA, and former Director General, National Informatics Center, Government of India, New Delhi. Thank you. Good day. And we close the seminar, leave studio.
Thank you. Thank you.